So guys, now let us begin with the route search algorithm. So you can see that we have an mtry data structure on the right hand side, and at this point of time these 5 routes have already been inserted into this mtry data structure. So it simply means that we have inserted 5 routes. It means this mtry data structure would have 5 leaves. Now we will going to discuss how to search a particular route in this mtry data structure. So when I say searching a particular route, it means that given a route, let's say 128.128.0.0/16, I need to come up with the answer yes or no whether this route is present in this mtry data structure or not. So route search algorithm is based on exact match bit by bit, including the don't care. So for example, if I am looking to compare the bit 1010 with the bit pattern 101x, and if I ask you the question whether these 2 bit patterns are equal or not, or whether these 2 bit patterns exactly matches or not, the answer is that they do not matches. And the reason is simple. The last bit here is 0 and here the last bit is a don't care bit. So exact match means that each bit between the 2 bit patterns which are being matched must exactly match. Even the don't care bit has to match exactly with the don't care bit on the other side. So for example, let's say another example, we have a bit pattern here 101x. Does it exactly match with the bit pattern 101x? And the answer is yes. Alright. So exact match means that even don't care bit has to match exactly with the complementary don't care bit on the other side against which the comparison is being done. Having said that, now let us see whether we are able to search the route 128.128.0.0/16. So the very first thing that we need to do is to compute the effective prefix of this route. So the following is the effective prefix of this route. Now route search algorithm begins with the root node again. The very first bit of the effective prefix is 1, so I will take a path along the 1th child of the root node and I will land at the node number 3. The node number 3 has a prefix length 8, so I will going to compare the 8 bits of the effective prefix with the 8 bit of the effective prefix of the node 3, and they exactly matches. Alright, so if they exactly matches, then I will continue to traverse the mtry downwards. Now the next bit in the effective prefix is 1, so I will take the path along the 1th child of the node 3 and I will land at the node number 8. And the node number 8 has a prefix length of 24, so I will going to compare the next 24 bits of the effective prefix of the input route with the 24 bits of the effective prefix of the node 8, and I see they exactly matches. Alright, and my entire 32 bits of the input effective prefix has been exhausted, so I will stop my search here. Alright, so it simply means that the node number 8 is a matching node and it corresponds to the route 128.128.0.0/16, which is this one. Alright, so this is how I search a route in the mtry. So I will return true that hey, such a route is present in the routing table. Let us execute the route search algorithm for another example. So for example, let us suppose that I want to search this route in this mtry data structure. So again, convert this route into its effective prefix. Now start your search from the root node again. Since the first bit of this effective prefix is 1, I will take a path along the 1th child of the root node and I will land at node number 3. The prefix length of the node number 3 is 8, so I will going to match 8 bits of the route that is being searched with the 8 bits of the effective prefix of the node 3, and they exactly matches. So I will continue my search down the tree. The next bit in the input effective prefix is 0, so I will take the path along the 0th child of the node 3 and I will land at node number 7. The node number 7 has the prefix length of 8, so I will try to match the next 8 bits of the input effective prefix with the 8 bits of the effective prefix of the node 7, and I find that they exactly matches. So I will continue my journey downwards. The next bit in the effective prefix of the input is don't care. So I will take the path along the don't care child of the node 7 and I will land at node number 6. Now the prefix length of the node number 6 is 16. So I will going to compare the 16 bits of the input route with the 16 bits of the effective prefix of the node 6. Alright, and they exactly matches, and my input effective prefix has been completely exhausted. So I will stop at node number 6. So it would simply means that the route is present in this mTry data structure, and the node which holds the data corresponding to this route is the node number 6. Alright. Similarly, if I want to search the route 128.128.0.2/32, then again compute the effective prefix of this route and start your search from the root node of the mTry. Since the first bit of this prefix is 1, so I will take a path along the 1th child of the root node and I will land at node number 3, whose prefix length is 8. So I will going to compare the 8 bits of the input effective prefix with the 8 bits of the current node, which matches. Alright, so I will inspect the next bit of the input prefix, which is 1. So I will try to traverse down the tree along the 1th child of the node 3, but the 1th child of the node 3 is null. There is no path. So it simply means that this particular route is not present in this mTry data structure. At any point during the traversal in the mTry data structure, starting from the root node down the tree towards the leaf, if you ever find that you have nowhere to go, then it means that that particular route is not present in this mTry data structure. Alright. Here I cannot descend down the mTry data structure further because the 1th child of the node 3 is null and I cannot reach to the leaf node of the mTry data structure. Alright. So it means that this particular route is not present in this mTry data structure, as simple as that. So you can see that searching a route in the mTry data structure is very simple and straightforward. You just keep on comparing the bits of the effective prefix of the input route with the effective prefixes of the nodes as we traverse down the mTry data structure, and it is mandatory that you should end up with some leaf node in the mTry data structure by the time your effective prefix is completely exhausted. Then only that particular leaf node is the matching node corresponding to your route which is being searched.